In this video, we'll be discussing the concept of a z-score, and I'm going to do this by first explaining the concept and then giving you a demonstration of an example problem. The most basic way that you can understand what a z-score is a z-score produces a number, and the way you understand that number is that number represents how many standard deviations a data point is from the mean, either above the mean, meaning to the right of it, or below the mean. Now, if you've watched the previous couple videos, you're getting pretty used to seeing this chart, which is a normal distribution with the mean, x bar at the center, and then split up by standard deviations. So the calculation for a z-score is given by the following. Z is equal to x minus x bar over the standard deviation. Now, that looks like a complicated formula. You say you only have letters up there. How do I understand that? It's actually easier than you think. So the z-score is going to be produced by doing this subtraction followed by this division. Let me give you an example of how this is useful and what a z-score would look like. So here's an example from the text. We're comparing two people, their SAT score and their ACT score. So two different math standardized tests. John scored a 572 on the SAT math score. The mean score on the SAT math was 460, and the standard deviation was 112. Let's calculate John's z-score for that data. Okay? The mean and the standard deviation we already know. So x is going to be the specific data point that we are interested in this case, John's score. So 572. I'm going to subtract that from the mean, which in this case is 460, and I'm going to divide that by the standard deviation, 112. When I do that calculation, you're going to come up with an answer of 1. Because this ends up being 112 divided by 112, which is 1. So how do you interpret? It's more important to me that you understand how to interpret this number 1 than you can just get it. If you just get it but you don't understand what that means, it's not that helpful to you. A z-score is how many standard deviations is a data point from the mean. Since this is a positive z-score, it means that this data point is above the mean. And you should already be able to know that because we can see that the 572 is clearly higher than the 460. But how much higher in comparison to standard deviations? Well, it happens to be exactly 112 higher his score than the mean, which is one standard deviation. So this number 1 means if we were to plot where John falls in relationship to all the people that took the SAT math, he would fall right here, one standard deviation above the mean. Now, the question is, if we compare John's relative performance to another person's performance on a different test, comparatively, who had the better performance? Since they're taking two different tests, we need something that brings the comparison together, and that's what the z-score is going to do with us. So, let's do the exact same thing for a different test. Bev scored a 28 on the ACT math portion. The mean was 18. The standard deviation is 5. What is Bev's z-score? We're going to repeat this exact same process to find her z-score. So z is equal to the score we're interested in, 28, minus the mean, 18, divided by the standard deviation, 5. When we calculate that out, we end up with 10 over 5, which is 2. So Bev's z-score is 2. Again, how do we interpret that? Well, Bev, relative to everybody else, scored 2 standard deviations, or z-score of 2, above the mean. That means if we were to plot her performance on the normal distribution, she would be not 1 standard deviation above the mean, but all the way up here at 2 standard deviations above the mean. She's even more above the mean than John was. So if the question is between Bev and John, relatively, who performed better on the test relative to everyone else who took the test, the answer is Bev did because she's 2 standard deviations above the mean, or a simpler way to say it is she has a bigger z-score than John did. So when you're comparing 2 z-scores and you're looking at who achieved better on 2 different tests or 2 different metrics, the answer of who achieved better can always be as simple as what is the bigger z-score. I'm going to do one more video on another, actually a homework problem that'll be assigned to you that'll be similar to this. But I want to point out that it's very possible to have a negative z-score. If you end up with a negative z-score, the way that you interpret that is that your score is just below the mean, meaning to the left of the mean. If you had a z-score of 0, that would mean you are exactly on the mean. Any z-score that is negative is going to be to the left of the mean. And one more time, the number you get when you get a z-score means how many standard deviations are you above or below the mean.